Hi everyone, I'm Chen. Today I want to give you a perspective of how an ASIC manufacturer looking into the mining market. Yeah, I'm Chen. I'm very early on blockchain mining hardware. Since 2011, I'm designing early FPGA miner for Bitcoin. And later we do 8th generation of Bitcoin mining ASIC from 110 nanometer to 16 nanometer. And yeah, so this very interesting things when people discussing mining and ASIC, people always discussing about centralization. Yeah, ASIC cost centralization? Maybe, but may not. And in the history, back to 2013, when the first Bitcoin mining ASIC comes out, maybe only a couple hundreds of chips can occupy 1% of the hash rate. And at that time, the network is very small. But today, if you want to centralize the network, you need millions of machines, and it costs billions of dollars, and it takes even you have that many, it takes years to manufacture and deployment. So that environment is already gone forever. It cannot be come back again. And we go through the simple economic of miner. For a miner, the chips, like ASICs, graphic chips, GPU, and memory is the major cost of a miner. Maybe 80% or more. It is, yeah, but people will feel, okay, if you are the chip manufacturer, you are NVIDIA, or you are other chip manufacturer, you will have significantly lower cost for the chip. It is correct. Maybe NVIDIA have 60% margin. So people will think it will cost centralization by the chip manufacturer self-mining. Yeah, it happens maybe possible 5 years ago. If you want to self-mining, you need a lot of money to spend. For example, you need building. Yeah, you need transformers, you need rack, you need land. If you want if you only deploy 1,000 miner, then maybe exist building already enough. Maybe you can buy a second-hand transformer. But if you want to deploy a million miner, that is not enough. So you need brand new buildings, you need a lot of lands, you need older transformers. This everything you will pay. And it's roughly $200 to $300 to install a machine. If you have a million machine, you need at least 200 to 300 million money to only install them. And also, during operation, you need a lot of cost. Electricity, repair, human monitoring, and stuff, everything. It can be, yeah, also costs a lot. Yeah, what do you think NVIDIA or AMD or use their GPU cost benefit or advantages to do self-mining? Yeah, maybe not. NVIDIA make a chip use $40 and sell it by 100. So it have $60 profit, and maybe it. But how would you spend them to buy land, to build building, borrow transformers, and wait it pay back in years, or you put the money back to development to make better chip for gaming, make better chip for AI training. So they are a very sure business. Yeah, people will buy GPU for better gaming, and people will buy GPU for AI. But do your investors will pay for you invest your money to do some mining, the puzzling business? No one knows the business model. For linear or business, we are designing. We think the centralization is not caused by hardware. It is business model caused the centralization, and the environment that happens 5 years ago, 4 years ago, and it's never again. In other business area, when you see, okay, why we want to buy new GPU? Because it is faster, it is more efficiency. We want to buy them for better gaming, and we want to buy better fiber optics for higher transmission speed. But when people discuss blockchain, we want slowable hardware, and everywhere we can see slowable. Our algorithm need more memory, need more logic, need more cycle to make it slowable. But hardware is not the enemy of a blockchain and not enemy for any application that we provide efficiency. In our machine, we are designing a Ethereum ETC mining ASIC, and we provide we use only 1/8 of energy to provide same hash rate, same security to the network. For example, Ethereum Classic now have 18 terahash global hash rate. It roughly means 600K GPU, and the power is average 150 watts per GPU, so it is 90 million megawatts, 90 megawatts in the whole system. And if you calculate Ethereum, it is roughly 1.3 gigawatts. The power is roughly 1 million family use. And we do a new project, Lava Snow. We provide 1/8 of energy efficiency. So our machine is 1.4 gigahash per second. So compared to Bitmain's 180. And the power is only 1,000 watts. So a machine daily revenue is 20 compared to Bitmain's $3. And based on current coin price, it provides 4 months ROI on mining income. And if we use this machine to replace GPU, we can save roughly 80 megawatts of 90 megawatts on ETC blockchain. And we can save 1.1 gigawatts on ETH networks. We think in the end, mining hardware will be a utility to provide network security. And it will be stable and long payback. And but it can save energy. It reduces average network cost. For the future of useful hardware, in our vision, I think proof of work still have a very good, bright future. In early age, there are only Bitcoin. Bitcoin is using SHA-256. When you mine it, you only need logic, no memory needed, no interface needed. So people do a lot of optimization on logic efficiency, logic speed. So people get roughly 1/10 of energy on every operation using ASIC. It provides a lot of increasement, and chip companies are using that technology to do AI, do other things. It is a lot of optimization on other industry also use Bitcoin-related technology. And later, there are Litecoin comes combined with memory, so people start optimize memory, how memory optimize operation in low voltage, how to reduce power, how to reduce area. Yeah, because that is not that important before. When Ethereum Classic comes, yeah, the internal memory is not enough. We need off-chip memory, DRAM, high bandwidth memory, other memory. So we need I/Os connect the chip and other chips. So also different types of technology are emerging. And if you have logic, memory, and I/O, the three things combine already the whole computer. If you have the three things, you can do everything a chip can do. So we think it is a good path to a useful hardware, a useful proof of work, to also provide more useful things to customer. For example, now we are talking about security of network, but it's not users' experience. Yeah, we said, okay, we provide double performance, double security for the network, but you can't directly feel it. Yeah, but if you buy a fiber optics, double the speed, you can feel it. Yeah, but later, proof of work can provide better experience on when you use it. Yeah, that's our vision. Yeah, so that's it, my presentation and any question.
All right, thank you very much. Does anybody have any questions on ASICs? Come on, ASICs are a hot topic. Somebody's got to have some sort of question on them. Okay, right here.
Hello. So you were saying that the ASIC was projected to release April 2019. Is that correct?
Right.
Yeah. Yeah. Wow. Yeah. Those specs are absolutely like those are amazing in comparison to like what's out there right now. That's pretty awesome.
Yeah.
So in comparison to Bitmain's 180 there. What are you guys doing differently to produce that hash rate?
Yeah, I think hardware is always about optimization. For example, today you find, okay, optimize a heat sink can improve 10% performance, and tomorrow you can see, yeah, you modify the voltage and you can see 10% of improvement. And ASIC is a group of a lot of optimization. And it gives you a lot of flexibility. And yeah, the key thing is improve memory bandwidth, and we do a major improvement in memory bandwidth. So we got very good performance and very low power. Yeah, it's roughly 8 times higher performance and 1/8 the power in the same time compared to GPU.
Wonderful. Thank you so much.
All right. I actually have a question, though. What's the efficiency of like these versus a GPU? Because I know in Bitcoin, ASICs completely destroy GPUs. How do these compare to GPUs? And like a regular GTX 1080, how much faster is this? Is it like 2 times faster, 10 times faster?
Yeah, if you compare GPU and this, it is roughly 1/8 the power and 8 times the performance.
Okay, cool. All right, well, thanks again to Chen.